Yes, good afternoon. Myself, Dr. K. Narender. I am working as Associate Professor in the Department of ECE. Uh, my college name is St. Peter's Engineering College. Today, my topic is signal analysis. So, signal science system is one of the basic subject to understand the remaining communication subjects like analog communication, digital communication, control systems, wireless communication, satellite communication. If you want to understand the better subject in the remaining communication subject, we should gain some knowledge in the signal science system side. So before going to analysis the signal, first of all we have to define that what is signal actually. Signal, in the many cases we are going to be discussing about the signals practically and theoretically. So here I will try to give the theoretical answer. A signal is nothing but a information. Many cases we have some doubts how we can define the signal and how we can define the communication. A signal is nothing but which contains the information. But what do you mean by the communication? Communication is nothing but the transformation of information from one point to another point is called a communication. So that is the difference between the signal and a communication. Mathematically also we can define the signal. Signal is nothing but it is a function of one or more independent variables, but it must contain some information. uh, X of t, for example, x of t equals to sine t. X of t equals to sine t. Here the t is the independent variable and x of t is the dependent variable. Means the each and every value of the independent variable time t, here x of t signal is going to be defining here. So sine t, the graphical representation of sine t will be like this. Means here the independent variable is time t and the dependent variable is a x of t. What it represents for each and every value of the independent variable, here x of t signal is having some information. So here we have the one independent variable, that is time. Depending upon the values of the independent variable, here the x of t signal is going to be defined. So like that we can easily define the signals in mathematical way. Signal is a function of one or more independent variable, but it must contain some information. So many examples we can take. So generally signal which contains some information, communication is nothing but the transformation of information from one point to another point. So here I am going to give the types of the signals here. So here the depending upon the independent variable, there are two major classifications of signals are there. That is, first one is continuous time signal and second one is the discrete time signal. Then what is the difference between these two? So here the continuous time, what is continuous time signal and what is the discrete time signal, and what is the mathematical expression for both, and what is the graphical representation for both, how we can differentiate these two signals here. Continuous time signals, it's a continuous time signal is nothing but a signal which varies continuously, with respect to the time t. That type of signals are called continuous time signal. Just now I told you here the independent variable is time t and dependent variable is x of t. Means the each and every value of the independent variable, here x of t signal is going to be defining. For example, I am taking here x of t equals to sine t. If you want to consider any x of t, any exponentially decay signal or exponentially rising signal, the type of signals also we can give the continuous representation. We can give the continuous representation here. For suppose here the exponential decay signal is there, means what is the general form of the exponential decay signal? X of t equals to e to the power of minus at. Here the again the dependent variable is x of t and the independent variable is t. Here also same, for each and every value of the independent variable, here exponential decay signal is going to be defining. So very simple, continuous time signal is nothing but a signal which varies continuously with respect to the time t, that is nothing but a continuous time signal. Means in the continuous time signal, the time axis and the amplitude axis both are in continuous form. Both are in continuous form means at t equals to 0 we have some amplitude, at t equals to 0.1 we have some amplitude, at t equals to 0.3 we have some means like that for each and every value of the independent variable. Here the x of t signal is having the information. So that's why we can easily define the signal is a function of one or more independent variable, but it must contain some information is called a signal. So depending upon the independent variable, here two types of signals are there, that is continuous time signal and discrete time signal. What do you mean by the continuous time signal? Continuous time signal is nothing but a signal which varies continuously with respect to the time is called continuous time signal. Then what do you mean by the discrete time signal? Discrete time signal is very simple. It is simply a sampled version of the continuous time signal. It is simply a sampled version of the continuous time signal. So here the independent variable time is represented by the small n and the dependent variable is represented by the x of n. Just now I told you it is simply a sampled version of the continuous time signals. Means here for example I am considering the sinusoidal signal. So now I am doing the sampling of that sinusoidal signal. So here the samples are represented like this, like this. So here means let here the 0, here is the 1, here is the 2, here is the 3, here is the 4, like that till infinity. We have the some sampling period among the successive samples. That sampling period here we are denoted by the ts. Here we are denoted by the ts. So in the discrete time signal, the time is in the sampled version, means it is simply a sampled version of the continuous time signal. Again the amplitude is in the continuous form, is in the continuous form. So what is the general example for the continuous time signal as well as the discrete time signal? Consider the analog watch. Analog, in that analog watch, we have the short hand, one long hand is there and one seconds hand is there. In that analog watch, the seconds hand is continuously varying. With respect to that only, the long hand will be varying. So here also we can give the similar thing here. The each and every value of the independent variable, here x of t signal is going to be defining. But in the discrete time signal, what will happen? Wherever the particular sample is there, at that particular sample only we have the information. Here I am considering the digital watch. Digital, per suppose we the time is 9:30 a.m. 9:30 a.m. till 0 to 60 seconds we have the same information. Here we have the same time, that is the 9:30. When 61 second will become, then the time will be changed from 9:30 to 9:31 a.m. So here also same, till 0 to 1 we have the some information, from 1 to 2 we have the some information, from 2 to 3 we have the some information. Like that we can divide the continuous time signal and continuous time signal and discrete time signal. These continuous time signal and discrete time signal can be classified into some following signals. Those signals are periodic signal and aperiodic signal. Second one is even, and odd signal, even and odd signal. Third one is a deterministic and random signal. Deterministic and random signal. And fourth one is energy and power signal. Energy and power signal. Let one by one we will see. This continuous time signal and a discrete time signal, both signals are can be classified into following signals. Those signals are here: periodic and aperiodic, even and odd signal, deterministic and random signal, and energy and power signal. Let's see what is the periodic signal first. What is the periodic and aperiodic signal? Periodic is nothing but, for that one here I am considering the x of t equals to a sine 2 pi f t plus pi. This is the general mathematical representation of any signal. Generally signals are having the three main characteristics, that is in the form of amplitude, frequency and phase. To give the clear explanation about the periodic signal, here I am considering the sinusoidal waveform. See what will happen. Here I am giving the graphical representation to better understanding of the periodic signal. See here, this is the time t independent variable and x of t is the dependent variable. Let here is the 0, here is the 1, here is the 2, here is the 3, here is the 4, 5, 6, 7 and 8. Now with the help of this graphical representation we can easily define that what is a periodic signal. First I will give the definition. Periodic signal is nothing but which repeats at an regular time interval, that is called the periodic signal. Which repeats at an regular time interval, that is called periodic signal. How? See, the first cycle of the sinusoidal waveform starts at 0. That first cycle is ended at 2, and the second cycle is started at 2 and end at 4, and third cycle is start at 4 and end at 6. Like that the fourth cycle is start at 6 and end at 8. Then what is the meaning of that? Here the first cycle is having the time duration is 2 minus 0, that is the 2, the duration of the first cycle. See, the second cycle's duration is 4 minus 2, that is nothing but 2 here. The third cycle of the sinusoidal waveform having its duration is 6 to 4, that is 2, and the next cycle is having its duration is 8 minus 6, that is 2, that is 2. Means the each and every cycle is having the same time duration. Means 0 to 2 we have the time duration is 2 seconds. The same cycle is going to be repeated from 2 to 4. The same cycle is going to be repeated from 4 to 6. The same cycle is going to be repeating from 6 to 8. Means all cycles are having the same time duration. Means the at every regular time interval the same cycle is going to be repeating. Same cycle is going to be repeating means the each and every cycle is having here same time duration. So a signal which repeats at a regular time interval is called periodic signal. For this signal the fundamental time period is 2 seconds. 2 seconds. When we have the time period we can easily calculate the frequency. What is the frequency? Frequency is nothing but reciprocal of the fundamental time period. What is the units for the frequency? Hertz. For this signal the frequency is 1 by 2, means 0.5 hertz is the frequency for such a sinusoidal signal. So here I am giving here I have given the clear explanation about the periodic signal. Periodic signal is nothing but a signal which repeat at a regular time interval is called periodic signal. Periodic signal. So from that one From that case, we can give the periodicity condition. What do you mean by the periodicity condition? Just now I told you in the definition, same cycle is going to be repeating. So here x of t is a signal is repeating at a regular time interval, that is capital T. That is capital T. This is the periodicity condition in periodic signal. This is the periodicity condition. So this is the periodic signal in the continuous form. What about the discrete form? Discrete form is nothing but it is again simply a sampled version of the continuous time signal. So here also in the discrete time also we can give the periodicity condition. The explanation is the same, just here the variables will be changed. For the discrete time signal, x of n equal to x of small n plus capital N. Capital N. This is the periodicity condition. According to that only we can easily give the periodicity condition for periodic signals. So next one is the non-periodic signal. What non-periodic signal are? Aperiodic signal. Periodic means which repeats at a regular time interval. But what about the aperiodic signal? Aperiodic signals means which do not repeat. Which do not repeat. The type of signals are called aperiodic signals. Aperiodic signal. So what is the example for the aperiodic signal? Exponentially decay signal. This exponential decay signal is continuously varying with respect to the time t, but there is no any repetition in that signal. Just that decay signal is continuously varying. There is no any repetitions. For such signals, we can consider in aperiodic signals. Periodic which repeats. Aperiodic means which do not repeat. So that's about the periodic and aperiodic signal. And next one is what is even and odd signal. What is even and odd signal? Even and odd signal. With the graphical representation, I will give you better explanation to better understand of even signal and odd signal. It's very simple. See here, I am considering one signal will be like this. Okay, this signal is having its a waveform like this. Here is a 0, here is a 1, here is a -1. Let this is the dependent variable is x of t, independent variable is t. I am giving the mathematical wave x of t equals to x of minus t. X of t equals to x of minus t. What is even signal? Even signal is nothing but inversion of time axis does not change the amplitude of the message signal. Inversion of time axis does not change the amplitude of the message signal. See in this graphical representation at x equal to 1, what information we have? At x equal to 1 we have the information is 0. Same for the inversion of time axis means now I am considering x equal to x of 1. The inversion means at x of minus 1. At x of minus 1, what information we have? At x of minus 1 also we have the information is 0. Means inversion of time axis does not change the amplitude of the message signal. The type of signals are called even signals. Even signal. So for continuous time signal, we can give the mathematical expression x of t equal to x of minus t. For the discrete time signal, we can give the mathematical way x of n equal to x of minus n. X of n equal to x of minus n. So this is about the even signal. What about the odd signal? So odd signal also very simple to define. Here also I will give the one graphical representation. With the help of that we can easily understand that what is the odd signal. What is the odd signal? Let this is the dependent variable, this is the independent variable, this is 0, this is time axis 1, this is the -1. Let here we have the information is 1. Let here are the peak information is -1. According to the odd signal, inversion of time axis does change the amplitude of the message signal. Inversion of time axis does change the amplitude of the message signal means, for better understanding, I am considering t equals to 1. At t equals to 1, what is the x of 1 value? X of so here we will consider 0.5, here minus 0.5 will be there. Here I am considering 0.5. At t equals to 0.5, we have the information is 1. When t equal to minus 0.5 means inversion. Inversion means x of minus 0.1. What is the information here we have? Here we have the information is minus 1. Minus 1 means inversion of time axis does change the amplitude of the message signal. Means at x of 0.1 we have the information is 1. That inversion means x of minus 0.5 we have the information is minus 1. But in the even case, the inversion of the time axis does not change the amplitude of the message signal, but in the odd signal the inversion of time axis does change the amplitude of the message signal. So that is the difference. Here we can write x in the continuous time signal, x of t equal to minus x of minus t, like that we can give the mathematical expression. The next signal is deterministic and random signal. Deterministic and random signal. The name itself indicates that deterministic. In the signal analysis side, we can easily define that what is the deterministic signal. Means any signal which can be represented by a mathematical equation. Any signal which can be represented by a mathematical equation, the type of signals are called deterministic signals. Any example you can take, x of t equal to sin t, or x of equal to e to the power of at, and exponentially rising signal, exponentially decay signal, any square wave, any triangular wave. Mean such a type of signals we can give the mathematical representation. Sinusoidal key we have the mathematical equation. Okay, for exponentially rising signal we have the mathematical expression. For exponentially decay signal we have the mathematical expression. For unit step signal we have the mathematical expressions. Means these type of signals we can easily give the mathematical expressions. Means a signal which can be represented by a mathematical equation, the type of signals are called deterministic signals. Next one is a random signals. Random signals means which cannot be represented by a mathematical equation. For example, ECG signal is there, and electrocardiogram signal. When we will go to the hospital, if we are taking any ECG signal, in that report we can signal see like this. In that report we can see the signals like this. For such signals we cannot give the mathematical expressions. ECG signal, it provides the doctor and give the information about the patient's heart. So the variations in the heart we cannot give the mathematical expression for such signals. Why? Because different people are having the different ECG information will be there. So those are the some random signals we cannot give the mathematical expression. And one more is EEG signal. EEG signals nothing but electroencephalogram signal. The signals provides the doctor will give the information about the patient's brain. If you find the report of any EEG signal, there also you will find the signal like this. Like this. We don't know exactly at what time we are having the different amplitude. So such signals we can consider under the random signals. And very simply we can define, no need to give that much of explanation to understand the what is a deterministic and what is a random signal. Very simple definition: a signal which can be represented by the mathematical equation. Such type of signals are called the deterministics, which cannot be represented by the mathematical equation. Such signals are called the random signals. Very simple: which can be represented, which cannot be represented. Very simple definition, easily we can understand. What do you mean by the periodic? Which repeats at a regular time interval, that is periodic. And what is aperiodic? Which do not repeat, that is aperiodic. And what is even signal? Inversion of time axis does change the do not change the amplitude of the message. Odd signal, inversion of the time axis does change the amplitude of the message signal. Like that. What is the deterministic? Which can be represented by mathematical and which cannot be represented by mathematical, that is called random. So, and the last signals are energy and power signals. Energy and power signal. Generally, when we are considering and when we are talking about the signals, generally every signal is having some energy and power. Then how we can calculate? There is some formula will be there to calculate what is the energy of the particular signal. In case of the continuous time signal, x of t equals to integration of minus infinity to infinity mod x square of t into dt. That means the signal should be 0, in between 0 and infinity, having means that should be a finite value. Same for power also, x of t equals to the limit t tends to infinity. Why? Because in the continuous time signal the independent variable will be continuously varies, so that's why the limit t tends to infinity, integration of minus infinity to infinity mod x square of t into dt. In this power case also, we that signal should be give its power in between 0 and infinity. So with the help of these two signals we can easily calculate the energy. With these two formulas we can easily calculate what is the energy and what is the power of a particular signal. Like that, in the discrete time also we can give, in place of the t, if you submit the variable n, then also we can easily calculate. There we will get the sum x of n, and summation will be there, and summation n equal to minus infinity to infinity mod x square of t into dt. And one more is x of for the power x of n equals to 1 by 2 n plus 1 summation of n equal to minus infinity to infinity mod x square of n mod x square of n. Yes. So that is the representation of energy and power signal in continuous time signal as well as in the discrete time signals. Thank you. In the next video we can see the complete signal analysis.